Assalamualaikum warahmatullahi wabarakatuh. We from Group 1 is going to present about the experiment 1, which the title of this experiment is Marcet boiler. Our group members consist of Abdul Aziz, Amirul Hakim, Ahmad Fawaz, Chawan J, and me myself, Nur Batrisha. So I will start this presentation with the abstract of this experiment. So this experiment is to determine the relationship between pressure and temperature for saturated steam. When the pressure increases, the temperature will also be increased because pressure is directly proportional to the temperature. And from the derived formula and the data that we obtain from this experiment, we can calculate the slope of the graph. The dt over dp was calculated is then compared with the actual data in the steam table. So the data in the steam table and the recorded values should be almost the same. And if there any error if there any difference in reading, it is due to some error that was made during this experiment. So the objective of this experiment is to observe the relationship between the pressure and temperature for saturated steam. Next, introduction. Thermodynamics is a physics branch that studies the interaction of energy between a system and surrounding that occurs when the system undergoes a process. The change in properties of fluid also is the concern in this thermodynamics. Most of the substances in thermodynamics are often referred as PVT substance. For an ideal gas, it obeys an equation of state that relates the pressure, density or specific volume, absolute temperature with mass of molecule, and gas constants. Unlikely gas, ideal gas, real gas does not obey the equation of state. When the energy in the water increases, the activities among the molecules will be increased that enable the molecule to escape from the surface until it is equilibrium, which also known as boiling point. The state of equilibrium depends on the pressure of water surface. So if the pressure of water surface is low, less energy is needed to achieve the state of equilibrium. So I think that is all from me. Next, Amirul, my friend, will continue with the theory. Thank you.
Next, I will briefly explain about the theory for this experiment. So, the thermodynamic properties of a pure substance could be determined by two of the following characteristics: temperature, pressure, enthalpy, entropy, volume, and other characteristics. Data characteristics could be obtained either from experiments or equations or using certain. Among two thermodynamic properties that usually measured are temperature and pressure. This is used in the Marcet boiler experiment. Relations between these properties could be expressed in the form of graphs or equations. Clapeyron equation 1 has published the following: dt over dp, the difference in temperature over difference in pressure saturated, equals to temperature in brackets volume of steam minus volume of water over enthalpy of water minus enthalpy of steam. HFG, HF minus Hg is the heat dormant of vaporization. Dormant for the heat value of water can be obtained from the equation. Moving on to the apparatus for the experiment. Here is the Marcet boiler, and here is a list of the apparatus on the Marcet boiler. Number 1 is the overflow or drain valve. Number 2 is the heater inside the boiler itself. Number 3, the overflow valve. Number 4, the filler plug. Number 5, the safety valve. Number 6, the temperature sensor. Number 7 is the manometer. The manometer is used to calculate the pressure inside the boiler. Number 8, the boiler itself with insulating jacket. Number 9, the temperature gauge right here. Number 10, the heater switch. And then number 11 is the master switch to turn on or off the Marcet boiler. Next is the methodology for the experiment. Number 1, the filler plug is open to fill in the water into the boiler. The overflow or drain valve is made sure to be fully open. Second, the filler plug is closed and tightened using a wrench once the water has overflown through the overflow valve. Number 3, the master switch and the heater switch are turned on. Once the boiler has reached the temperature around 97 to 100 degrees Celsius, the overflow valve is closed. 4, the temperature for each increment of 0.5 bar of pressure is recorded into the table until the pressure reaches 5 bar. Finally, the heater switch is turned off after reaching the pressure of 5 bar, and the temperature for each decrement of 0.5 bar is recorded into the table.
Let me explain our result. First, this is the data collected and calculated by our group. We had the raw data in gauge pressure and the steam temperature in this increasing and decreasing pressure. For absolute pressure, we can refer one equation, that is absolute pressure equals to gauge pressure plus 1, so that we can get the value of all the absolute pressure. For how to get the value of measure slope and calculate the slope will be discussed later. In the result, we are required to draw the graph of pressure in bar versus time in Celsius for the heating and cooling process to determine the slope of the graph. So here is the absolute pressure versus steam temperature increasing pressure. This is the heating process graph. So the slope for the graph is 0.101, while the next graph is absolute pressure versus steam temperature in decreasing pressure. This is the cooling process graph. So the slope for the graph is 0.0967. Next, we are required to calculate the value of TBG over HFG using the table 2, that is saturated water and steam table, which is provided in lab manual and need to compare with the slope of the graph. The mean temperature, which is Tmin, can get by using the increasing temperature plus decreasing temperature and divided by 2. And we had to convert the unit temperature from Celsius to Kelvin. Next, for the measure slope, that is dT over dP. dP can get by using P2 minus P1 and change the unit from bar to kPa. And dt also can get by using this method, that is P to P min 2 minus P min 1. Unit changes is due to get a better comparison between the measure and calculated slope. While for the calculated slope, we can get it by using Tmin times specific volume of steam divided by the specific heat of evaporation, which is Vg and HVD. Lastly, we found that there are a deviation between the measured slope and the calculated slope.
Good morning, everyone. So, coming to the discussion, as it refers to the graph 1, it shows the relationship between the absolute and the saturated steam temperature for heating process. So, while the graph number 2 shows the relationship between the absolute pressure and the saturated steam pressure for the cooling process. Here, the plotted graph that we have from this experiment is a straight line for both the cooling and the heating process, as we saw in the result in the graph above. So for graph 1, it's a heating curve where there is an existence of the vapor phase, and for graph 2, it's a cooling curve where there is an existence of the liquid phase. And before the experiment was undergoing, the pressure was 0 and the temperature of the water was at room temperature. So during the heating process, as the pressure increases, the temperature also increases. For graph number 2, the line that we have for the cooling process is quite the same as the heating process. So in the cooling process graph, the temperature where pressure is 0 is higher than the initial temperature of the heating process. So heat loss need more time. Yeah, here heat loss need more time, and it can be seen clearly on both graphs. And before the experiment, the cleanliness of the Marcet boiler should be taken in consideration. And water heated while the wash valve is open. And from the result above, we clearly observe that there is a deviation between the measured and the calculated slope. There are some errors that can affect the accuracy of the result between the theoretical and the experimental data. So this will be the end for the discussion part. Thank you.
So, and the last one is our conclusion for this experiment. So, Marcet boiler is a device that we use to study the relationship between pressure and temperature for water at saturated liquid phase. So, based on what we see on the video for this experiment, that we find that the relation in between pressure and temperature is directly proportional to each other. So the difference between the theoretical values and the actual value is caused by many errors, such as like parallax errors and also systematic errors. So in order to get a better result, so we need to reduce this error so that we can get a better and also accurate result for this experiment. So that's all from our group. Thank you.